Going to do a couple quick examples where we combine some exponent laws together. This is the second section in your Exponents workbook. So for this one, I've got negative 7b exponent 7 times 8b exponent 12. So when we're doing something like this, it might help you to rearrange, since all I'm doing here is multiplying. So I can rearrange and I can move all my coefficients to the front, and then I can have my variables coming after. Okay, so if it's going to help you to keep things organized, by all means move things around. So negative 7 times 8 is negative 56, and b exponent 7 times b exponent 12, they have the same base, so I can add the exponents together and write that as b with an exponent of 19. Okay. For something like this, where now I've got things combined here in a fraction, so again, I'm going to look at my coefficients first, and I'm going to rewrite this as just 20 over 8 as its own separate fraction. And I'm going to then have another fraction for my e's. So I got e exponent 9 over e exponent 4, and then another fraction for the f's. Because it doesn't really matter what order I multiply and divide in, as long as I do all the multiplication and division. Okay, you're allowed to do it in whatever order you like. So when we look at the coefficients, 20 over 8, we could put that into lowest terms. Both have a common factor of 4, so I'm going to get 5 over 2. Okay, so I'm left now with 5 over 2. And for the e's, I would subtract those exponents. 9 minus 4 gives me e with an exponent of 5. And f exponent 12 divided by f exponent 8, subtract those exponents to get f exponent 4. Now you didn't need to separate them into the different fractions. By all means, you could have just done the exact same thing here and put this into lowest terms and then used your exponent laws to simplify your variables. So you don't need to split things apart, but if it's going to help you keep things organized, go ahead. Okay? Alright, so let's look at something a little bit more complicated. So here my numerator is 72x exponent 4, y exponent 11 times negative z squared in a set of brackets and then an exponent of 4 outside, all divided by 6 times, and then in brackets we've got 3xy squared, and that is cubed, times z with an exponent of 7, and then y with an exponent of 5. So we've got lots going on here. Okay? First thing I'm going to do is I am going to actually work with my 72 and my 6, my coefficients. I'm going to put that into lowest terms. So 72 is divisible by 6, and I get 12 over 1. Okay, so that works out nicely. So as I go to start my next part here, I'm just going to have a 12 up top. Okay, so for my numerator, the x exponent 4 is fine. I have no problems with that. For the y exponent 11, no problems with that one either, so I'm going to write that there. But then in brackets here, so we've got this negative z squared to an exponent of 4. Okay, so that z is the base. Okay, so if I'm looking in here, the z is the base. So this exponent of 2 is directly touching the z, so it is not impacting the negative. Okay, but then the exponent of 4 outside, that one is impacting the negative because the 4 touches the brackets. So that's helpful because that means I'm going to have 4 negatives, which means I'm now going to have something that becomes positive. So I'm going to have a positive z, and then multiplying those exponents together, 2 times 4 gives me an exponent of 8. Okay, so there's my simplified numerator. In the denominator, so I already got rid of the 6, that's become a 1. So let's look at this here, this first set of brackets. So in that first set of brackets, I've got 3xy squared, and then it is then cubed. So my exponent law tells me that each thing inside the brackets, each factor in the brackets, needs to get that exponent of 3. So 3 cubed is going to give me 27, and then x is going to be raised to an exponent of 3. And y squared is going to be raised to an exponent of 3, but since we already had an exponent on there, those exponents will multiply. So I get y exponent 6. Now I've got z exponent 7 and y exponent 5, but I'm going to move the y exponent 5 next to my other y, because I want to have all the things that are similar grouped next to one another. Okay, so there's my simplified denominator. Alright, so with this one now, again, I can put these things into lowest terms. 12 and 27, they both have a common factor of 3, so I'm going to be left with 4 and 9 when I put that into lowest terms. Okay, so now I've got 4 over 9. Okay, and it's up to you if you want to keep the line for the whole fraction going across, or you can just simply cut it off here. I'll leave it going across just so we can kind of see what's happening. So as we look at our x's, okay, x exponent 4 divided by x exponent 3, that means we can subtract our exponents. 4 minus 3 gives me an exponent of 1, so I just get x. For the y's, okay, in the y's, I've got y exponent 11 over, and in the denominator, I've got y exponent 6 times y exponent 5. So these guys would add together to give me 11, and 11 minus 11 is 0, so I get y exponent 0, which is really just 1. So that cancels out all my y's. And then when we look at the z's, z exponent 8 divided by z exponent 7, subtracting those exponents, we get an exponent of 1 again. So we just get z. So if you'd like, you can rewrite as 4 over 9 times x times z. Okay, so that's something a little bit more complicated. Just looking at here, in your book they give you some crazy ones here, where we have not only variables in our base, but also variables in our exponents. We can work with variables in our exponents, so this is going to follow the exact same exponent laws. So this tells me b with an exponent of 5x plus y is divided by b with an exponent of 2x minus 2y. Okay, so b is my base. And since b is the base, and it is the same in the numerator and the denominator, I'm allowed to subtract my exponents. So I'm going to be careful here, and when I write these exponents out, I'm going to put them into their own set of brackets. So my first exponent is going to be subtracted by my second exponent. Okay, and so now in my exponent I actually need to do some work with polynomial subtraction. So remember, that means I'm going to have 5x plus y, and instead of subtracting, I'm going to add instead of subtracting, and I'm going to add the opposite. So I'm going to change each symbol from positive to negative, or negative to positive. So positive 2x now becomes negative 2x, and minus 2y is now going to become positive 2y. Okay, so now my statement says b with an exponent of 5x plus y plus negative 2x plus 2y. All right, so 5x minus 2x is 3x, and y plus 2 more y is 3y. So now my exponent is b. I've got b with an exponent of 3x plus 3y. Okay, so we're allowed to combine all our different exponent laws. You could see a question that has every single exponent law contained in it. I think this example number 3 pretty much had everything in there. So just be aware that everything can get combined and put together, okay? And we are allowed to have variables in our exponents. All right.